Alright, welcome back. This is episode 13, I figured it out. Last episode was episode 12 apparently. Right, so we're going to continue where we left off last time, which is... Oh, we're already in disk. Nice. Edit query. Oh, Jesus. Okay, so what I said last time was going to create a function that allows us to move to a certain location. So what that means is, let's say we're at minus 164, 195, y72 here, and I want the turtle to go all the way over here to say minus 180 and z170, and it is 77y. Just writing that down for a reference in a minute. So, let's get started. So, let's open this up. Now then, where did my test go? Here we go. Get rid of this, don't need this anymore. So the function we're going to make, I'm going to call it go-to, and it's going to have the robot go to a certain place on the map, certain coordinates. Now to do this, this is going to be our first function that uses variables or parameters that are given to the function and then can be used in the function. So what we're going to do is we're going to give it the parameters x target, z target, and y target. And these are going to be the coordinates that we want the robot to go to. Or the turtle, I should say. Don't know why I'm calling it a robot all of a sudden. That's kind of what it is. So, let's think about this a minute. Here's my good preparation I have every episode. I have no idea what I'm doing. So let's start with going up and down. I think that would be a good place to start. So we need to obtain the same y coordinate that is equal to the y target. Now we have to go either up or down, or if we're lucky we don't have to move at all, so we're going to have to check that. So what we're going to do is create an if statement. If, I don't need that, y coord, so that's our current y coordinate, is smaller than y target, then, so this means that our current y coordinate is lower than where we need to be, so that means we have to go up. So we're going to go while y target is smaller than y coord, do move up. So that's the move up function we made ourselves. That will also edit our coordinates for us and move the turtle. Now you may notice here that this if statement is checking the same thing that this while loop is also checking. So in reality this if statement is not actually doing anything useful whatsoever. Because if this if statement fails, this while loop would never get entered anyway, so we might as well just leave the if statement out and only have the while loop there. So while the y target is smaller than the y coordinate, then move up. And if you're not lower than the y coordinate to begin with, then it will never enter the while loop. So you don't have to worry about going up when you're not supposed to. I'm trying to get to the right position to move these two back. There we go. Right. Perfect. Now we need to do the same for if you are above your target. I think I might have made a mistake here. So if y target is lower than the y coordinate you're at, oh here we go, yeah, this is supposed to be down. My bad. So let's say your y target is larger than your y coordinate, that means you have to go down. No, that means you have to go up. Making the same mistake I did just now. Right, move up. Because the target is above your current coordinates, you have to go up. There we go. So, we've got that sorted out. Now remember that, because because of the way we made this, the turtle's going to destroy everything in its path. So you've got to be a bit careful about where you send it, because right now, if you were to send it to a Y coordinate under him somewhere, might be, you know, over there. I don't know. It'll immediately start digging down first and get to the right Y coordinate. So you've got to think about where you send it, and make sure it's not going to be digging through things you don't want it to dig through. That's one of the disadvantages of the way I've implemented this whole thing. But with a little bit of thinking, you can live with that. Alright, so we've got the right Y coordinate now. Now we need to somehow figure out which direction we have to go on the X and Z. So we have our X target. So let's say our X target is smaller than our X coordinate. Then, or in this case, let's do a do. Actually, let's do a then. Right. So the reason we're going to do a then, if then, rather than a while loop again, because we don't know which direction we're facing at this moment. Well, actually we do, we can look it up. But we don't know if we're facing the right direction. So we're going to have to check if we are, and if we're not, we have to change our looking direction. So if the X target is smaller than the X coordinate, that means we're going to be going in that direction, the direction I'm looking at now, because the X in that direction is smaller. You see it's going down, and that is the west direction, if I remember correctly. So we need to look west and then move forward. So I think it might be a good idea to create a function that we can use to say look west and have the robot or the turtle look west for us automatically. And then we'll do the while loop saying while X target is smaller than X coord, do and move forward. There we go. We haven't made this look function yet, so if we run this, it's going to give us a problem. So let's just create that function now. So we're going to make the function look, and it's going to have a variable, a parameter, that is going to call that direction. Right, so the very easy way to do this is to say while direction is not equal to this not equal to this thing on the left here. It's a little squiggly thing. Most keyboards will have it on the top left above the tab, and if you can't find it, good luck, because I don't know all the hundreds of different keyboard setups off the top of my head. So let's see, we have remembered all of our orientations up here in orientations array and our orientation. So what we can do is we can look up what our current orientation is by filling in orientation in the orientations array, and we'll get north, east, south or west. So we can check whether we are currently looking west or not. Go all the way down. Nope, that's too far down. There we go. So if the direction we want is not equal to orientations, our current orientation, and so we need to look in a certain direction. What we can do is just, you know, keep turning right until we get there, because we're bound to get there eventually. There's only 4 different directions. So we'll just go turn right, and that's it. I think that's what I called the turning functions. Not quite sure now. Move forward, turn right. Oh, it's just right or left, okay. Yeah, because the turtle one was called turn right. Oh, that was it. Right. then we just go right. So it's going to keep turning right until we get to the right direction, and then we'll stop. And then we know we're looking in the correct direction. So it's not completely, 100% efficient, because if you could turn left once to get to the right direction, rather than turning right 3 times sometimes, would be a possibility, but, this is 3 lines of code, which saves us a lot of typing and a lot of space. So we'll keep it like this for now. So we're going to look west, and then we're going to move forward until our x target is equal to our x coordinate. However, what if x target is larger than x coordinate? Then I guess we need to look east. And then while x target is larger than x coordinate, then move forward and that and that. Right, so that's our x coordinate fixed. Whoops. Right, so we've got a y coordinate, going to the correct y first, then we'll be going to the correct x, so I'll have that sorted. And now all we have to do is also go to the correct z, which is going to work in exactly the same way as the x. So I'm just going to have to type that out real quick. So our z target is smaller than our z coordinate, so we're going into the negative z, which is that way. That's north. Excellent. And when once we're looking north, then we'll go while z target smaller than the z coord, then move forward and that if z target is bigger than z coord, then look south, plink, and while z target is bigger than z coord, then move forward. Whoops. Might want to put that on the next line. Just realised I made a bunch of mistakes doing while then instead of while do, so I'm going to have to change that in a second. Large amounts of typing going on here. Alright, so that's all good. Now let's change these whiles to while do instead of while then. While do, if then, while do. I don't know why they chose to make it if then and while do, but oh well, guess we'll live with it. Alright, so I'm just gonna hope that that works now. Right, so remember what we had, the coordinates? I do, because I've written them down. So we had minus 180z, we had 170, minus 180x, 170z, and then 77y. That should do it. Just go to those locations and that should work. Likely thing is that I'm going to get an error. Of course, oh, I guess I missed one. Somewhere I'm doing a while then instead of a while do. That's a while do, while, oh, maybe this one. Oh, never even did do. Well, that's a problem. Try again. Oh, there it goes, there it goes. Oh, Jesus. Okay, so it's doing its Z coordinate first. That's a bit peculiar. I thought it would do the Y first, or the X first, but... Okay, I got one direction wrong, apparently. So, this is what happens when you make it turn into the wrong direction. This is going to go on forever. Because it's trying to get to a set... Oh, or is it not? That's interesting. That's very interesting. I'd expect it to go on forever. Oh wait, it doesn't have that, of course. Right, I'm going to do a little bit of debugging here. Oh, the wonderful world of fail. Alright, so the turning left and right, we already checked that was working properly. Move forwards working properly. So the issue, I think move up and move down we tested, that should be working properly. So the looking, is the looking going okay? I think I'm going to test that first. So 4, 1 to 4, do right, so we're gonna print our orientations, orientation, and then we're gonna turn right, see how that goes. Unfinished string, interesting. This is north and south. West and east, they're both finished. Oh, this one. Yeah, there shouldn't even be a quotation mark there. I guess I could say, looking at... Okay. Christ. We'll get there eventually. Oh, I guess I didn't close it. Is that the issue? Yeah, that is the issue. Okay. Please, God. What? God, you're gonna be kidding me. I guess I didn't save it right then. Okay, I did save it. Ah, yeah, here's the problem. Forgot the double dots here. Looking southwest. Is that the issue? And he's not turn. Do that again. Okay, he does turn around. Yeah, his looking direction is wrong. I think I forgot to change that back like 2 episodes ago. I remember. Yeah, because orientation is 3 at the moment. That doesn't make any sense. It's actually 4. Well, there's your problem. So now looking west. There he starts west, then north, then east, then south, then he turns back to west again. That's what we want. Alright. I'm quite confident that the actual go-to function should be fine. That the reason it messed up was because it had the wrong starting looking direction. Let's remove all of this. And we're going to go to try this again. Minus 180, 170, 77. So we expect it to go up first, and then move in the X direction, and then move in the Z direction last. So it's going to go up. It should go forward now. There we go. So now he's moving in the X direction. Now it should turn right and start moving in the Z direction. And there we go, right where we want him. Minus 180, 169, and Z70, or Y77, perfect. So that's pretty cool, right? Now you can send your robot wherever you want him to go, and he will go there to the right coordinates. I think that'll do for this episode. Next episode, we can start actually making it quarry and dig a nice big hole, which we can determine how big we want it to be and all that good stuff. So, hope to see you then, and thanks for watching.